Welcome back to Nutrition 101. As a reminder, this course follows Sizer and Whitney's Nutrition, Concepts and Controversies 16th edition, but I've made adjustments by skipping and arranging some of the material and adding my own images and information. This video covers Chapter 2, Nutrition Tools, Standards and Guidelines. The learning objectives for this lesson are to discuss the dietary reference intakes and daily values as nutrient standards, examine the dietary guidelines for Americans, explore the USDA Dietary Patterns to see the basics of diet planning and the MyPlate educational tool, and review food labeling and the nutrition facts panel. Chapter 2 begins by outlining nutrient recommendations. Nutrient recommendations are standards against which people's nutrient and energy intakes can be measured. In other words, they guide how much of each nutrient a person should or should not consume for optimal health. As such, nutrient recommendations help individuals understand how much of a nutrient they need. They also allow nutrition professionals to assess intake and provide guidance. In the United States, the two sets of standards include the Dietary Reference Intakes, or DRI, and the Daily Values, or DV. The DRI provides recommendations to individuals for all nutrients, including macronutrients, micronutrients, energy, water, and fiber. The daily values are used on food labels, as illustrated in this image of a nutrition facts panel. I've dedicated the upcoming slides to explaining both sets of standards in detail. First up, we have the Dietary Reference Intakes, or DRI. The DRI is a set of 5 lists of values for measuring nutrient intakes in the United States and Canada. Those lists are established by the National Academies of Science, Engineering, and Medicine, which includes leading researchers and scientists in nutrition and health. They evaluate the existing evidence for each nutrient and then create recommendations for both sexes and various age groups, a process that has been ongoing since 1997. The DRI is used to plan and assess the nutrient intake of healthy people only. It doesn't apply to people with diseases or nutrient deficiencies affecting intake requirements. To summarize, there's an organization called the National Academies. Within it is a committee of researchers and scientists who evaluate the existing evidence for nutrient requirements. They produce a set of 5 lists containing nutrient recommendations that are called the Dietary Reference Intakes. The United States and Canadian governments have adopted those lists. Here are the 5 lists that comprise the Dietary Reference Intakes. There's the Recommended Dietary Allowances, or RDA, the Adequate Intakes, or AI, the Chronic Disease Risk Reduction Intake, or CDRR, the Tolerable Upper Intake Levels, or UL, and the Estimated Average Requirement, or EAR. The RDA and AI are lists that provide recommendations for adequacy, ensuring a person has enough of each nutrient to maintain health and body weight. The CDRR identifies nutrient intake levels associated with risk reduction from chronic disease. The UL provides safety recommendations, keeping individuals below risk for toxicity, and the EAR is used in research and policy. Looking closer at each of these, we start with the Recommended Dietary Allowances, or RDA. This is a list of nutrient goals for individuals. They satisfy the nutrient needs of approximately 97.5% of people and are derived from solid experimental evidence and reliable observations. Thus, when the National Academies Committee evaluates the research surrounding a particular nutrient intake level for a specific age group and sex, there's a threshold for the quantity and quality of evidence that must exist for them to give it an RDA value. Adequate intakes, or AI, are very similar to the RDA, but they're established when there's insufficient evidence to generate an RDA. Adequate intakes are more like an educated guess. The committee has a general idea of what people in an age group and sex need to thrive, yet they don't have enough evidence to give the nutrient an RDA. Then, for chronic disease risk reduction, or CDRR, I already mentioned how these reflect a nutrient intake level that will lower the risk of chronic disease. CDRR is the newest list and was added to the DRI in 2019. At present, sodium is the only nutrient that has values for it. A high sodium intake is associated with an increased risk of high blood pressure and heart disease, so keeping sodium intake under control is essential for prevention. The CDRR is less than 1,200 milligrams per day for ages 1 to 3, 1,500 milligrams per day for ages 4 to 8, 1,800 milligrams per day for ages 9 to 13, and 2,300 milligrams per day for ages 14 and older. Finally, we have the tolerable upper intake levels, or UL, and the estimated average requirements, or EAR. The UL represents the highest nutrient intake level that poses no risk of toxicity. These are most likely to be surpassed with dietary supplements, as many are difficult to reach through food and beverage selections alone. The EAR is a list of nutrient values used in nutrition research and policy. They satisfy the needs of approximately 50% of people and form the basis for the RDA. So, they are similar to the RDA in that there's an EAR for nutrients by age group and sex. Still, they're not meant to be applied to individuals because they cover an insufficient percentage of the population. To see how the EAR forms the basis for the RDA, we can pretend that we're conducting an experiment on a nutrient only found in broccoli. To see how much broccoli someone needs to eat to maintain normal bodily function and avoid deficiency, we feed our subjects bowls of it. At first, we find our subjects have all different daily requirements. However, as we test more and more subjects, a trend begins to emerge. Eventually, we're able to establish what the average daily requirement is. That average requirement covers approximately 50% of the population and becomes the EAR. You wouldn't want to recommend that to everyone in the given age group and sex because at least 50% would fall short of their daily requirement. Therefore, you make the RDA close enough to the highest daily requirement to cover approximately 97.5% of the population. This way, you can recommend it to everyone in the population and have pretty good assurance that nobody will develop a deficiency. You wouldn't want to go to 100% or higher because at that point, people who sit on the lower end of the range for the daily requirement will run the risk of developing toxicity. Here's another way to look at the DRI. Starting from the left, with zero intake, there's near certainty that a deficiency will develop. As nutrient intake increases, you pass the EAR, and by the time you get to the RDA, the risk of deficiency is minimal. There's a decent cushion for safe intake after that until the nutrient intake passes the UL. At this point, the risk of toxicity begins to increase. With insufficient evidence to produce an RDA, there's uncertainty about where the AI lands, though it's somewhere between the EAR and UL because there appears to be a low risk for deficiency and toxicity. Here are some key takeaways for understanding the DRI. First, the DRI makes recommendations based on sex and age group. For example, the RDA for iron for males ages 14 to 18 is 11 milligrams per day. Second, the DRI applies to healthy people only, with healthy defined as the absence of disease. Therefore, the DRI does not apply to those with the deficiency or disease that affects nutrient needs. Third, all values are based on probability and risk. That means going above or below the recommendations does not guarantee toxicity or deficiency, it simply increases the risk. And fourth, all values reflect daily intakes to be achieved on average over time. A person does not have to meet their nutrient needs perfectly every day to maintain normal health and function. Day-to-day fluctuations in nutrient intake are normal. This chart shows the RDA and AI for the vitamins, meaning it reflects the recommended daily intake for individuals. Numbers with no asterisk represent the RDA, and numbers with an asterisk represent the AI. The recommendations are stratified by age group and sex, and there are some similarities and differences between each one. Another relevant item from the National Academies is the Acceptable Macronutrient Distribution Range, or AMDR. The AMDR outlines the recommended energy contribution from carbohydrates, protein, and fat. According to the National Academies, 45 to 65% of our diet should consist of carbohydrates, 10 to 35% of protein, and 20 to 35% of fat. For example, we can imagine that Mr. Jones eats approximately 2,000 calories daily. After analyzing his diet, we find he gets 1,100 calories from carbohydrates, 400 calories from protein, and 500 calories from fat. To get the percentage of total calories, you take the contribution from each macronutrient, divided by 2,000, and then multiply the result by 100. In this case, we see he falls within the recommended ranges. This doesn't tell us anything about the quality of his food choices, but it does suggest his diet is well balanced, with no overemphasis on one macronutrient at the expense of the others. Last but not least, we'll examine the daily values, or DV, which are nutrient standards used on food labels and restaurant signs. This set of standards was developed by the United States Food and Drug Administration, or FDA, not the National Academies of Science, Engineering, and Medicine. The DV represents the highest RDA or AI across sexes and ages 4 and above. For example, the DV for iron is 18 milligrams per day, which is the RDA for females ages 19 to 50 who have the highest RDA due to regular iron losses through menstruation. As a result, the DV does not serve as reliable recommendations for individuals. Still, it allows for the general comparison of foods. For instance, if a person is told they have low iron stores and should be trying to increase the iron intake in their diet, they may look at two similar foods and want to choose the one that provides a more significant amount of it. Here, we see the Chewy bar provides 2% of the DV for iron, while the Lara bar offers 15%. In a perfect world, companies could list the nutrient needs of both sexes and all age groups. Yet, as we saw earlier, that requires a large table of numbers, and it's just not practical to fit it all on the packaging. Alright, that closes out the first learning objective. Discuss the dietary reference intakes and daily values as nutrient standards. Now, we'll examine the Dietary Guidelines for Americans. The Dietary Guidelines for Americans is a document published by the United States Department of Agriculture, or USDA. The first edition was published in 1980 and has been revised every 5 years since then. So, in 2015, the USDA published the Dietary Guidelines for Americans 2015 to 2020, which was the 8th edition. Then, in 2020, they released the Dietary Guidelines for Americans 2020 to 2025, which is the 9th edition. In 2025, they'll publish the 10th edition, which will be for 2025 to 2030. Put simply, the Dietary Guidelines for Americans offer food-based strategies for achieving the DRI. In other words, it takes recommendations from the national academies like the RDA and the AMDR. Then, it presents them in the context of food and beverage selections to satisfy the recommendations. The dietary guidelines cover the nutrient needs of both sexes and all age groups. It also covers the nutrient needs for pregnancy and lactation. The current iteration of the Dietary Guidelines for Americans has 4 key recommendations. Follow a healthy dietary pattern at every life stage. Customize and enjoy nutrient-dense food and beverage choices to reflect personal preferences, cultural traditions, and budgetary considerations. Focus on meeting food group needs with nutrient-dense foods and beverages and stay within calorie limits. And limit foods and beverages higher in added sugars, saturated fat, and sodium, and limit alcoholic beverages. Then, within those key recommendations, you have more specific guidance. For example, the key recommendation to focus on meeting food group needs with nutrient-dense foods and beverages has the following suggestions. For vegetables, we should aim for dark green, red, and orange colors and include legumes. For fruit, there should be an emphasis on whole fruit. For grains, at least half should be whole grains. For dairy, we should choose fat-free or low-fat milk, yogurt, and cheese, or fortified plant-based alternatives. For protein foods, we should choose lean meats, poultry, eggs, and seafood, with lean meaning they are low in total fat. And for oils, we should account for vegetable oils and oils in food. Then, for the key recommendation to limit foods and beverages higher in added sugars, saturated fat, and sodium, and limit alcoholic beverages, there are more specific recommendations for each item. We should limit added sugars and saturated fat to less than 10% of total calories. We should limit sodium to less than 2,300 milligrams per day. And alcoholic beverages should not exceed 2 per day for adult males and 1 per day for adult females. The dietary guidelines attempts to make these recommendations easy to understand by providing visuals like the one shown here. Now, if you spend enough time looking for nutrition information on the internet, you may eventually find some discussion about how the dietary guidelines for Americans are making us sick. The basic premise of these discussions is that the United States government either has a fundamental misunderstanding of what a health-promoting diet is, and by following their recommendations, Americans have developed a high rate of obesity and conditions like hypertension and diabetes. Or they know what a health-promoting diet is, and they're giving us incorrect information on purpose to make people reliant on medications and other healthcare services. Well, for any of this to be true, you would need a population that actually follows the recommendations, which unfortunately has not been the case. This graph shows the average healthy eating index scores from 2005 to 2016, representing how closely Americans' diets align with the dietary guidelines. With a maximum score of 100, Americans have performed poorly, with scores ranging from 57 to 60. Zooming in closer at the data from 2015 to 2016, we can see averages stratified by age groups. Young children ages 2 to 4 and older adults ages 60 plus perform the best when measured by this standard, while children and adolescents ages 9 to 18 perform the worst. So, it's not necessarily that the dietary guidelines are incorrect. A more obvious explanation is that they don't get followed like they should be. Okay, that closes out the second learning objective. Now that we've examined the dietary guidelines for Americans, we'll explore the USDA Dietary Patterns to see the basics of diet planning and the MyPlate educational tool. First, we have the USDA Dietary Patterns, which we can imagine as an extension of the dietary guidelines that help people understand what they should eat. The Dietary Patterns is a diet planning tool that sorts foods into 6 food groups. It specifies the number of servings people should eat from each food group. If followed, it should satisfy the nutrient goals outlined in the dietary guidelines. The recommended servings in the USDA Dietary Patterns are written in cups, ounces, or grams per day, and each food has nutritional equivalents to simplify counting them. For example, when looking at the USDA Dietary Patterns, Mr. Jones sees he should aim for 8 ounces of grains daily. 1 ounce is equal to 1 slice of bread, 1/2 cup cooked rice, pasta, or cereal, 1 ounce dry pasta or rice, 1 cup ready-to-eat cereal, and 3 cups of popped popcorn. Here are the nutritional equivalents for all 6 food groups from the dietary guidelines and the dietary patterns. Most of the servings are in cups and ounces. Then, the nutritional equivalents are more specific to how foods in each food group are prepared or consumed. Servings for oils are sometimes written as teaspoons per day with nutritional equivalents for different types, but currently, the dietary patterns has them in grams per day. Servings per day for each food group are then organized by calorie level. After all, the foods in each food group contain calories, meaning someone with a higher calorie need will need more servings than someone with a lower calorie need. Thus, a person must first know their recommended calorie level to use the dietary patterns. They can find that information using charts provided by the National Academies or the USDA, like those in the dietary guidelines. Some food groups also include recommendations for subgroups of foods, such as the different types of vegetables and grains. We see this again within protein foods. Putting these concepts into play, to use the USDA Dietary Patterns, a person finds their calorie level and the corresponding servings from each food group. Then, they attempt to eat in a way that satisfies all of the requirements. To be precise, this would not only involve keeping an active log of everything that's consumed. It would also require measuring food using cups, spoons, and a scale. Knowing this takes time, effort, and commitment, the USDA also produced the MyPlate educational tool. This image of a plate with 5 of the 6 food groups on it is meant to guide meal building. In theory, if someone were to model their meals after MyPlate, they would eat in a way that aligns with the dietary guidelines and USDA dietary patterns. MyPlate was launched in 2011 as a replacement for MyPyramid. It contains a comprehensive web page that helps people navigate their unique nutritional needs. There's also an app that people can download to a smartphone or smartwatch and receive assistance with learning and food tracking. That ends the third learning objective. Explore the USDA dietary patterns to see the basics of diet planning and the MyPlate educational tool. Now, we'll review food labeling and the nutrition facts panel to close things out. Quite obviously, food labeling deals with the labels found on foods, but it also deals with beverages. Most packaged foods and beverages are required to have a label. The Nutrition Labeling and Education Act of 1990 established this requirement, making labeling a federal law. Under this act, specific items that must appear on the label include the common or usual name of the product, the name and address of the manufacturer, packer, or distributor, the net contents in weight, measure, or count, the nutrition contents of the product, which is found on the Standardized Nutrition Facts panel, ingredients listed in descending order by weight, and essential warnings for potential allergens. The Food and Drug Administration, or FDA, regulates food packaging. So, they outline what companies must put on the product, and they also monitor for accuracy and compliance with standards. Here's an example of food labeling using honey-made graham crackers. The net contents are 408 grams, and the common name for graham crackers is grams. The manufacturer's name and address appear just in case there's an issue with the product that needs to be traced back to the source. There are warnings that the product contains wheat and soy, so those with sensitivity or allergies can avoid it. The ingredients are listed in descending order by weight, meaning the ingredient listed first appears in the highest quantity. Lastly, the nutrition contents are listed within the Nutrition Facts panel. The FDA mandates all of these items. Food labels can also include voluntary information, such as the nutrient claims no high fructose corn syrup and 8 grams of whole grains per 31 gram serving. As I mentioned previously, the Nutrition Facts panel is standardized so that all of the panels appear exactly the same. The Nutrition Facts panel begins with the serving information, which is essential because all of the information below is for one serving, and a container may contain multiple servings. Then, we have the calories per serving in large bold lettering, followed by the quantity of various nutrients. Some nutrients have subgroups, like the proportion of fat from saturated fat, and the contribution of added sugars to total sugars. The 4 micronutrients listed at the bottom of the label, vitamin D, calcium, iron, and potassium, are nutrients Americans consume too little of. So, having them there is to help people increase their intake of them. Finally, the daily values represent the highest nutrient recommendation for both sexes and all age groups. They are most helpful in making general comparisons between foods. The FDA states that a daily value of 5% or less is low, while a daily value of 20% or more is high. That concludes our fourth learning objective and the lesson. As you continue this course and we explore the specifics of individual nutrients, you'll encounter many of the concepts again. If you want to check out parts of the chapter that weren't covered, here are the sections I recommend.